Hi, and welcome to this part 8 in our video series on the V-block project. In our last video, we looked at producing the clamp and we completed the clamps. And today, well, we're going to be wrapping things up and we're going to be completing our blocks. 3 blocks that we're going to complete in 2 different ways. 2 of the blocks are going to be heat treated in a traditional fashion and surface ground. And the 3rd block, well, is going to be heat treated home style on a propane burner and finished by hand. So let's get to it. We start our heat treatment with the oven preheated to 1550 degrees Fahrenheit. Once the parts are inserted into the oven, they have to soak for a certain amount of time. In this case, around 20-25 minutes will do nicely, or until they reach the same color as the oven. Remember, the bigger the part, the longer they have to soak. Once you're satisfied that the parts have reached their quenching temperature, pull them from the oven. Get someone to help you here. It's important that the door be closed as soon as possible because we're doing 2 parts and we don't want that second part to cool down before quenching. Note that I'm pulling the parts from the oil before they cool down completely. I'm pulling them when they're somewhere around 400-450 degrees. Now this is important to reduce the chances of the part cracking before they make it to the tempering oven. And in order to avoid smoking out the whole shop, remove the excess oil from the blocks before inserting into the tempering oven. Now the tempering oven is set around 550 degrees Fahrenheit and the parts will stay there for somewhere around 1 hour. And here again, the larger the part, the longer the soak. You would usually count about 30 minutes of soaking per inch of thickness. After the parts have tempered, pull them from the oven and let them cool slowly on a refractory brick, not on a cold steel workbench. We then start the grinding process by removing the scale from one and only one of the primary surfaces of the part. Primary surface is the largest surface on the part. Once that is accomplished, we're going to lap the part to produce a nice flat surface that we can use to sit on the grinder's magnetic table. Here I'm using a diamond dresser to flatten the grinding wheel's working surface and to make it nice and sharp. I can then start the grinding process by grinding my reference surface, which is going to be the primary surface opposite to the surface that I lapped earlier. Now this surface that I'm grinding is going to be my reference surface for all the other exterior surfaces except for the V itself. And there's one good looking reference surface. Now between each grinding operation, do not forget to deburr your part properly. Now burrs from grinding operations may be small, but they can really wreak havoc on precision. Once my reference surfaces have been ground, I can move on to grinding the opposing primary surfaces, and since they both have to end up the same dimension and I want them to be a match set, I'm going to grind both at the same time. And there, my primary surfaces are complete. I can now move on to my secondary and tertiary references. Here I'm setting up my secondary reference with a dial gauge in order to remove the least amount of material possible. Now, just make sure that this surface is as parallel as possible to the surface plate. For this technique to work, you need a very accurate square. Now, this square is very accurate, so it will ensure that my part, once ground on its secondary and tertiary surfaces, will be as square as the square was to start with. But for that to happen, I have to grind both surfaces, secondary and tertiary, without removing the part from the square. That is why I am indexing the square here without, and this is important, without moving the part on the square. That means that my tertiary surface that I'm about to set up will be as square to the secondary surface as my square is square, and it will be as square to the primary surface as my square is square. This is starting to sound like that old child song. How much wood would a woodchuck chuck if a woodchuck could chuck wood? He'd chuck all the wood a woodchuck could if a woodchuck could chuck wood. Sorry about that. Here I'm grinding my tertiary reference. Now, once the tertiary is complete and my secondary has been completed, well, all I have to do is grind the opposing surfaces parallel to these two references. And since they were all done by referencing from my primary surface, well, my whole block will end up being square. It's important, however, to note that when I ground my secondary reference, and now as I'm grinding my tertiary reference, I remove about half of the material, the total material that needs to be removed. And that means that when I grind the opposing side, I will remove the other half, and I'll do that accurately, and I won't have to come back to these first surfaces, the reference ones, because really I don't want to touch them again. Well, as I was rambling on there, I moved on to my opposing tertiary surfaces. You'll notice here that I'm doing 2 blocks at a time, again because I want this to be a match set, and it saves some time. Note also that I'm supporting the blocks at each end with 1 to 3 blocks, because remember, magnets hold very well in tension, but they do not hold very well in shear. That's why it's important to add material to just stop the parts from sliding. It's also important to note that the parts are supported at each end, but they are not attached to those 1 to 3 blocks in any way. I want the parts to rest freely on the magnet. I don't want the 1 to 3 blocks to affect the V block's positioning in any way. Now we can move on to the V. Now, I'm going to be grinding the V in a setup that's quite similar to the setup that I used for milling the V's out originally. And that is they're going to be nested in a very accurate V block and backed here by our very accurate square. Now, everything needs to be lined up quite well because the grinding wheel here is going to come pretty close to that second or the vertical side of the V here, but I do not want to touch it. These grinding wheels are not meant to cut on their sides. So we can see that I'm taking a light cut here on this end, and then once it's complete, without changing anything, I'm going to flip my blocks over and just cut the second side. Now, if your V's aren't close enough to do this right off the bat, well, you can grind one side a little more than the other, bring them close, and then on your final pass, dress your wheel and then cut each side without changing the depth of cut. And that will give you a V that is really truly centered. And since we're cutting both at the same time, well, we get our matched set. So here are our blocks, but the project isn't complete because we still have to produce that third block that we're going to heat treat home style and finish by hand. So here's my block. Now it's around 42 Rockwell, and that's going to be important later on, and we'll see why. But what we want to do now is start finishing our reference surfaces. And I need three. I need a reference in my primary surfaces, a reference for my secondary surfaces, and a reference for my tertiary surfaces. So what is what? Let's start by saying that once I establish a reference, I have to be able to remember which one it is. Primary is the largest surface, so this will be my primary reference surface. This will be my secondary because it's the second largest, the bottom of the part. And the side of the part, especially since we have that groove cut out, well, is quite small, and it will be my tertiary reference. But there's pairs of these surfaces, and I have to know which of the two surfaces in any given pair is my reference surface, and I have to be able to remember that. And in my case, well, what I have that's asymmetrical here is I've stamped LM for lazy machinist in the bottom of one of the grooves. And I'm going to decide arbitrarily that all the three reference surfaces, primary, secondary, tertiary, the surfaces that are closest to the L are my reference surfaces. So if I look here, I have my L. This will be my primary reference. My L is down here, so this will be my secondary reference. And my L is here, so this side will be my tertiary reference. And it's important to know that because we're going to attack these surfaces in that order. And why is that? I'm going to be hand finishing with abrasive paper on a flat surface, my cast iron surface plate or a layout table. And I'm going to be finishing in that way. And I don't want to work for nothing. Now, the most difficult surface to work on is the largest one with this technique. So I want the most difficult surface to be the one that has the least complexity to it. So if I start with my primary reference, the largest surface here, well, all I have to do to that surface is make it flat. That's all I need to do. It is the simplest one to obtain. So I start with the largest one because all I have to do is one thing, make it flat. Then I'm going to be looking at the bottom here, my secondary reference surface. And I'm going to be finishing that in the same way, but it's more complex. So luckily there's less material to remove here. And it's more complex because it has to be flat, but it has to be perpendicular to my primary reference. Now, once I've completed my primary reference, I won't touch it again. I do everything else on the secondary. And once the secondary is complete, flat and perpendicular to the primary, well, I'm going to move on to my tertiary reference, the smallest surface. And it is the most complex to finish because it has to be flat. It has to be square to the secondary reference, and it has to be square to the primary reference. So there's a lot of work to do there. I got to get three things simultaneously. And believe me, for a Frenchman, that word is difficult to say. Once I have my three reference surfaces finished, well, I'm going to move on to the second in each pair of surfaces. So I'll do the opposing primary, the opposing secondary, and the opposing tertiary. And all I have to do to those opposing surfaces is to make them flat and parallel to the opposite surface. Now, seeing as I've left very little material on here for finishing, I'm not really worried about the dimension. Once I get this finished, or looking pretty, well, it's going to be pretty darn close to its proper dimensions. So let's start by attacking our first primary reference surface. There, you can see that we have a pretty good finish on that surface, and that is our primary reference surface. Now we want to work on our secondary reference here on the bottom of the part. And before I start working away, I want to verify with my precision square here what we're up against. If I look from one end to the other, I can see that this surface is slightly inclined in relationship to the reference surface I want to produce. And that means that I'm going to have to take a little bit more off the leading edge of this secondary reference than I would take off the trailing edge. That means that when I work the part, I'm going to want to bear down on the leading edge, the one adjacent to the surface I just finished, a little more than on the trailing edge. That's all there is to it, really. We're just going to work the leading edge a little more to get it to be square. I never said this was rocket science. Let's do it. There, I can see here that I'm touching a lot more on the leading edge than on the trailing edge, and that's what I want. Once you're happy with the flatness and the squareness of the secondary reference, well, it's time to attack the tertiary reference surface. Now we want to get this one flat and square to the two first references. Okay, so it's been about 45 minutes since the last scene, and well, I'm finally satisfied with the flatness and squareness of my three reference surfaces. So I have my primary, my secondary, and my tertiary reference surface. Now I have to produce the opposing surfaces to those references. And for that, well, I'll be able to dispense with my accurate square because I already have my references. All I have to do now is measure and ensure that over several measurements in different spots I have all the same dimension. And that will mean that my second primary surface, as an example here, will be parallel to my first. I'll do this same operation for the primary surfaces, the secondary surfaces, and the tertiary surfaces. So it's going to be a while. So let's start lapping. So there's my block, nicely squared up. All the surfaces are done. All I have left to do here is to finish the V. Now, there could be a lot of work to do here, and I'm thinking of an alternative way of doing this. But before I do anything, I'd like to know what I'm up against. So I have an accurate V block here, and I'm going to set my V block in. Well, the other one's mine too. And I'm going to come with this dial indicator and just verify how close to zero I am, or how close to even, I should say, that I am. Well, that was actually quite close. The highest spot on both surfaces was about 1/1000th of an inch over zero, and the lowest spot was about 3.5 thou under zero. And that means that if I start at the highest spot, which is right here on the side opposite the identification number letters, if I start there and I take about 6/1000ths of an inch off and I flip the block over, I should be able to get this pretty centered, well within 1/1000th of an inch. And that's the tolerance I'm looking for. But what am I talking about? I finished the rest by hand, well because I wanted to see that, but also because it was an accurate way of doing it. But this V is going to be difficult to finish by lapping. Not impossible, but difficult. Because I'd have to use paper on a lapping block that I can come and work into the V. And that could take quite a bit of time. But this part is 42 Rockwell C. And that means that it's quite machinable. Now, high-speed steel tooling wouldn't hold up very long, but a carbide end mill will. So I'm going to use my 2-flute carbide end mill just to come and skim this part in a little jig on, not a jig, in a little fixture on my mill. So let's take a look at that. Okay, so I have an accurate V-block, and my V-block is sitting in the accurate V-block. Now, it's sitting there. This V-block is fixed solidly or bolted to an angle plate, and the whole assembly is solidly fixed to the work table. Now, my part is held in there by the pressure applied by this finger clamp on this brass cylinder, and that pushes downward and towards the opposing V. That's important because it really limits the movement. But I'm going to be cutting here with a lot of pressure, and I want to be sure everything is going to stay put. So I've added this stout C-clamp with a little shim here to protect the surface finish of my part, and this C-clamp will hold my part up against the angle plate. Now, as far as I'm concerned, this is more than enough holding power to do the job, and we should be able to cut safely here. As long as we do one thing, and that is put on our safety glasses. So here's our 3 blocks: surface ground, hand finished surface ground. They're all quite accurate, but the surface ground ones are a little more accurate. They're within 1/1000th of an inch, and this one here within 1.5 thou, 2 thou. It's still quite acceptable. So here we see we can hold square stock, small pins, not tiny, but small. This is 1/4 inch. and large diameters, this here being a 1-inch diameter. There you go. This project is complete. Our next project, I don't know yet, but I know it's going to be a lot shorter than this one. 8 videos, a bit much. But it was fun to do. So, until we meet again, have fun, be safe, and happy machining.